Welcome back, friends. We'll continue from where we left in the last session of the module. So, we'll call this as the part B, continuing from what we had learned before. So, what did we learn before? We discussed basics of inkjet printing, how photographic images can be printed, the continuous inkjet principles, drop on demand principles, and also advantages and limitations thereof. This is what we did last time. So, we shall discuss in this session various types of inkjet printing machines, some interesting issues with them, and the inks. Inks are very important and they really pose a lot of challenge, and therefore, there are not many manufacturers who make inks. So, let us start with the inkjet printing machines. So, what is the challenge? You see, the inkjet people were making machines for printing paper. Now, when you said where you are to make machines for textile, suddenly the requirements changed. So, the print head, which is the heart of the machine, which had to be managed with the kind of inks that textile people want. The electronics had to be adjusted. One of the challenge, of course, that remains is whether the electronics can withstand the conditions of the ink, aqueous normally that may be, and so whether the electronics can withstand that. The speed at which the fabric can be printed, this itself can be an issue, because the cost therefore depends on how fast you can print. The fabric has larger width, the printing head has to traverse a lot of distance widthwise. The surface of a fabric is not as smooth as a paper, and you want certain type of absorbency on the textile. Therefore, the ink drop would diffuse into the textile surface, and so this becomes additional requirement from the textile point of view compared to, let us say, what they were doing for paper printing. The print head is the most important part of the machine. This basically determines the resolution, the drop size, the dot size, how many dots per inch in a per square inch. That is what makes the design more sophisticated, and all that obviously is the responsibility of the so called print head. Remember the technologies that we discussed, these print heads may be using either continuous inkjet or drop on demand principle, but at the end of the day they must meet the requirement of the design. The sharp lines, the shade as desired. If it is a photographic image, then they must exactly do what is desired. And print head obviously means a lot of electronics is there, a good backup of a software, so that the drop is generated as desired, wherever desired it falls. Therefore, this whole thing is quite complex. All this is to be done with precision. The heads must house a large number of nozzles. All of them must get information as to when to eject. So, this is therefore a complex system, and that is the reason why this part of the machine will be the most costly part. And therefore, we can also say that the quality of the image which is generated through this print head would be determined by this head. And why? Because it can control the drop volume, and which means the size of the printed dot can be controlled. In the earlier days, the drop size volume could produce 100 picoliters. Now, therefore, the dot size was high. Now, one can actually think of very small drop volumes which could be as low as 1.5 to 2 picoliters, and that means the dot which is generated will be of small size. What therefore it also means is how many such dots can be placed in one unit area. So, that technology has been refined quite a lot, but the sharpness of the image therefore depends on what is the resolution and the dropped volume and the dot size. So, sometimes people do talk about something called a DPI, dots per inch printed, all right. So, let us say there is a value called 600 DPI, which means in that space each dot is separated by each other by approximately 42 micrometers. So, if you increase this resolution further, say 2400 by 1200 dots per inch square, that will become finally, or this DPI, that means 2400 dots per inch in the direction of motion of a carriage and 1200 dots per inch in the direction perpendicular to that. So, fabric is moving in one direction, the carriage is moving perpendicular to that. So, the carriage moves in this way, the fabric moves this way, all right. So, they can be similar, they could be different. This would obviously be dependent on the design of the print head and of course, supporting software. So, what happens if the dot size is larger than the resolution of the print head, all right. What happens if the dot size is larger than the resolution of the print head? So, there is always a chance that one drop overlaps the other one, then you can appreciate the quality of the print is going to go down, all right. So, resolution is one part. So, how many such drops can be generated per square unit area, per unit area, and what is the size? So, what is the maximum size will be dependent on, let us say something like this. So, if the dot size is this, what could be the maximum dot size? Well, it can probably go up to this point. So, what we are saying is, in case the drop size is more than this area, matrix area, then they will start overlapping and the quality can go down, all right. So, maximum that you can think is that they can at best touch each other, but not overlap. So, when you talk about resolution, this is 4 by 4 type of thing. So many drops can be put in different areas. So, the dot size can change on what? The drop volume and also the distance between the nozzle, bottom of the nozzle printer head, the print head, and the textile surface, because you said that this is it is not a contact printing, all right. This printing is the printer head therefore is separated from the thing. If the distance is large, then there will be an expansion in that manner and the drop size can increase. So, the distance obviously people will not like to change very easily, but if you print a paper, the surface is very smooth, but if you are printing a textile, the surface is rough, somewhere the distance could be more, because remember we are talking about very small areas, 3 picoliters let us say, very small dot size, and if this increases or decreases, some sharpness is going to be affected. So, if it overlaps, then the quality obviously goes down. Suppose by deliberate attempt we reduce the dot size, from this we bring it to this. So, resolution still remains the same, 4 by 4 type of environment matrix, but the dot size is reduced, number of dots are the same. How will it change our position? Can you think about it? So, the question that may have to be asked, what happens if the dot size is smaller compared to the resolution of the print head? All right. What happens? So, this is the question now we are asking. Obviously, the shade of this color is going to drop, it will get another grayscale. Why? Because more white is visible, right? Because the colored dot is smaller, that there are more spaces which will give an impression of the white. So, the shade will become lighter. So, this is deliberately we can do this. If we can change the drop size, we can change the shade, it is good. So, talking about the complexities, let us say a typical print head, we give the example of a Seiko 2020. It has at any given point of time about 255 active nozzles, right, one print head. The drop volume may be let us say 35 picoliters. It is expected to produce 20,000 drops per second. You look at the complexity now, a print head therefore is a complex part of the machine. And in a machine there can be 2 identical print head carriages and each may have 8 print heads. Now, so you have one color, why you have so many? You were only 4 colors, but then if you have more print heads let us say, then the production, print production can be increased, and that is what obviously you want to increase the speed of production. If you do not, then the cost becomes high. So, you are increasing the cost by putting more print heads, but if the production rate becomes higher, then obviously a kind of a compromise will be made based on what is the robustness of a print head. All right. So, it is a complex machine, complex system. The carriage speeds could be 20, 40, 60 inches per second, 40 being a nominal kind of a value. So, the whole expectation from this print head is pretty high. And interestingly, these may be very thin, maybe 1.5 mm thick. Within this everything has to be done maybe. There is a top sandwich layer which consists of hundreds of piezoelectric drivers which will be switching on, switching off. making sure a drop comes where the drop is required. It is already understood that there are, let us say, so many print heads and so many carriages, and which one is carrying which color. All that is software controlled electronic system, which will ensure that the right drop comes at the right place. So, you have a sandwich grid which contains drivers, and you have a layer of porous material which allows the ink to flow to the bottom layer which contains nozzles. All that could be very thin, because so many of them have to be put in the assembly. And therefore, this print head is not only just the hard, but is the most costly, one of the costly, very costly element of a printing machine. So, now the print speed, obviously, other than the resolution, depends on what do you want. If you want a resolution of 360 dpi and you are looking at high quality, then only, let us say, 22.5 square meter per hour can be printed. If you want high speed, quality will be reduced, then you can probably go for 66 square meter. Now, they are talking about square meter for printed area and not talking about linear meter, right. And if you have higher resolution, then obviously you want the speed obviously goes down, right. The production goes down, and you want high resolution and high quality, then at 720 you may be just nearing 11 square meters per hour. So, the printing production would depend on the resolution that you want and high quality resolution you want. So, therefore, you will be going slow. So, the productivity of a print head therefore is dependent on what is the volume of a drop, what is the frequency at which these print heads are working, and how many number of nozzles are active. And of course, we are talking about one print head, there can be many more print heads. So, the productivity of a print head pH is in a way directly related to the volume of the drop, the frequency, and the number of nozzles. Or sometimes they express the productivity of a nozzle, which is obviously volume versus the frequency. So, you are talking about how fast you are working, what is the displacement that your actuator is doing, and all that is part of the game. So, you must note before also, maybe we talked about the frequency at which the drop on demand systems work could be around 10 kilohertz, while the continuous inkjet systems work at an order higher frequency, which is about 100 kilohertz. All right. So, that is one difference, but we also talked about pulsating system, which can be 1 megahertz type of frequency as well. So, in general, we may say that if you want 100% coverage, which obviously nobody does, design is only a part of the whole surface, but if you do 100% coverage, we expect about 15 to 20 milliliters of ink per square meter for fabric. That means you do not require too much. The ink is costly, but you do not require too much. Think of that, per square meter only 15-20 ml. Therefore, you do save, but let us say at 50% coverage, you will be requiring half of it. At 25% coverage of design, you will require 1/4 of this. So, you can get beautiful impressions and designs at very less amount of ink, because there is nothing, nothing is being wasted, directly goes there. If everything is right, it gets absorbed. So, that was the print head. is there something called the pre and post treatment of printing? I mean, do we require it? And why do we require it? If that is so, then there must be some machines which must do this job as well. After all, remember, we are now dealing with textiles, all right, textile, which has a stringent requirement of a use, washing time and again, rubbing at any given point in time, and people expect all these fastness values also to be high. And textile is a rough surface. If there is too much of rough surface, too many hairs are protruding out of the surface, which may touch the print head, is not a good idea. All right. So, you may require some pre-treatment, you require some post-treatment. So, this digital inkjet printing as against digital printing of a paper is very different. Paper is not to be washed, paper will remain in a file or a folder, will not be exposed to the elements of the weather, but textile will be. And therefore, despite the fact that all the printing can be done in a sophisticated manner, you may require pre and post treatment. And so, let us see what. So, a typical printing machine therefore, would be having a feeder unit, which will ensure that right fabric in a right form is gone, a printing unit, a drying unit, and a folding unit. But that is one part, but you may require a pre-treatment. Why? Because now we are dealing with various types of inks. It could be an acid ink, it could be reactive ink, it could be a disperse ink, pigment. All of them require some chemicals and auxiliaries for fixation purposes. And these chemicals and auxiliaries we may not be able to incorporate in the printing ink itself, because they can damage or restrict the flow. And so, you may have to add these chemicals in a pre-treatment. So, the fabric has these chemicals, when the dye comes, then these chemicals can help the fabric, the dye to get fixed. Also, these pre-treatments can do many things. One of them is making sure the rough surface becomes little more smooth, but you can add them either by padding or by coating. You may be interested to avoid that the drop does not spread too much, because if the drop spread, the dot size changes, and therefore, or your earlier calculations which the software is doing for you may not remain a good thing, because the resolution may change, the quality may change, because the ink is now spreading, overlapping. You do not want that. So, to avoid the spread of the color, we may have to add some thickening agent to ensure that the drop remains exactly where it is supposed to and does not immediately go through the capillaries in the lateral direction, till we have come to the fixing point of it. So, there is a pre-treatment machinery, padding or coating. What will do? It will prevent bleeding of the inks from one area to the other and improve the feed performance. highly twisted yarn fabrics, for example, like crepes and georgettes. Their surfaces are rough, they stretch, dimensions can change. Stretch fabrics by themselves, for example, may have to be printed, which has got, let us say, elastomeric material yarn in them. Skewing has to be avoided and slippage has to be controlled. All that, therefore, a pre-treatment can do, and a pre-treatment machinery which could be simple padding or coating and drying systems. So, you pad, stretch, so the wrinkles are not there, and then of course, dry. If this happens, then the fabric therefore is ready to be printed. So, what does it have? It has some chemicals which are required by the ink. It has got some chemicals which make sure the surface is a little more smoother, the hairs are not protruding so much, the dimensions are controlled, wrinkles are not there, and then you try and feed. Then comes the printing. So, if somebody asks, this inkjet printing, is it a continuous printing process or an intermittent printing process? What do you think? It is intermittent, although the motors which actually do the work move to a very small distance, but they do move, all right, and they are stationary. If both printing head which is moving and the fabric continuously move, so you do not know where the drop is going to fall. So, you do the drop formation and the drop ejection which goes to the fabric, and in fabric moves a bit as per the desire, and then again. So, it is an intermittent process. The basic printing unit may be about 3 meter to 6 meter in size, and a typical machine would have roll on one side, and after printing, etc., the fabric after drying may be rolled again. The speeds obviously would depend on what is the printhead technology, as we discussed just before. The conditions which have to be maintained during this printing process are more controlled. Temperatures are around 20-25 degrees centigrade, and humidity also is controlled. So, compared to the rest of the printing process, conventional printing, the environment here is more controlled. Reasons are very clear, lot of electronics, and they must not misbehave. So, for a successful printing, entry should be nice, the fabric should be properly spread, tension should be maintained, so the dimensions are controlled, speed adjustments have to be done as per the design of the required design of the machine and the print head. So, there is a forward stepping motion with an accuracy of few microns. So, fabric moves to a few microns, stops, print head prints, then moves a few microns, and therefore, you are looking at a speed which is not necessarily the faster speed. So, optimum fabric feeding and transport is an important thing. Also, there may be a conveyor blanket where the fabric is glued, so that it does not change during the printing process, it does not change its position during the printing process, because then all accuracy will be finished, digital or not digital. And after all, after the fabric has been printed, it will be removed from the blanket. The blanket, when it comes back in the return, may have to go through some washing sequence to clean any gum, so that the next time when the gum again applied and you again stick the fabric. The printing stage has a carriage which moves crosswise. The fabric may be moving in this way, print head moves perpendicular to that. Speeds are adjustable. Another thing which we talked about was the gap. The gap between the nozzle and blanket surface can be adjusted. Some machines would give up to 40 mm, which is quite a large, but then larger the distance, the shape of the drop can change, the impact will be different, and but based on the type of textile, let us say you are printing a rug or a carpet, which obviously thickness is different, the fibers cannot be very controlled in that manner compared to, let us say, a simple shirting fabric. So, the machines would allow this gap to be changed. So, because they should be able to print flat fabrics, velvets, nonwovens, and so on and so forth. Ink. So, the print head moves one direction to the other direction. The ink can be fed or filled from both sides sometimes. These are called the stations, and you fill up the ink in this way and fill the ink from the other side, and then they move. So, all that happens during this process of printing. Then comes the ink. We talked about 4 color, but to get a more accurate shades, people are using these days 6 color, which may be orange and blue, or cyan light, magenta light, or they may have black light also to give more closer to the actual appearance of the design. Then you have a drying stage where the fabric is taken to the hot air and then finally rolled or folded. The machine may have post processing equipment, which would mean baking, steaming, washing. So, whether it requires baking, steaming, washing would depend on what fabric and what ink that we are using. So, pre-processing, printing, post-processing, all of that would be required for a good inkjet printed textile production. A typical machine therefore may have a fabric roll, which is endless belt where it may be pasted. This is the printer where actual printing is taking place. Then you detach and you go through the baking, steaming process, all right, or a dryer. So, it is a drying process and then folded or rolled, all right. It is a printing machine. Okay. After this, you can have either continuously or otherwise another steaming process or washing process, which is not here, or a pre-treatment system here and a post-treatment machines on the other side. Okay. Well, another term we like to introduce here. So, whatever we are talking about was called a multi-pass machine, where the fabric is moving in one direction, the print head is moving perpendicular. So, it is called multi-pass because on the same area or the same area of the fabric, you may find that initially yellow color was there and the red is the cyan is going, and so the head may be passing on the same area more number of times. It is called multi-pass machines. Whatever we are talking about, these are maximum number of machines that were generated, made, designed, developed were multi-pass machines. So, fabric moves here, all right, intermittently, of course it moves. The print head also moves in a cross direction, all right. Both these things are moving, and for this reason this is called the multipass, that goes like this and keeps on traveling, and the fabric may not have moved till all the colors in that area or the dots in that area were generated. These days, so what it is? It is multiple times the head is passing over the same area of the fabric, therefore it is called multipass. These days new systems are coming which are called the single pass machines. Now, single pass machine means that the fabric, the head only pass one time and the same area is not exposed the second time, right. So, this is what it means. Single pass, the same area is exposed only once to that print head. So, this has helped to increase the speeds of production tremendously. So, all big companies are now going to be making single pass machines. Of course, they are costlier, but the speed is increased. Now, what happens? The print heads are fixed in a stationary row or rows, one row, second row, third row, based on how many colors. And the fabric is moving. Obviously, we mentioned before, fabric can be printed. You can print a paper which can be used as transfer paper, sublimation paper, that also can be printed by these machines. So, speeds increase because one of them is stationary. Which one? The print head is stationary. The fabric moves, stops, moves, and this has increased the speed. A typical single pass printer may look like this. Let us say 6 color machine may have 6 rows, okay, rows. So many print heads may be there, or the whole thing is one single large print head, and all blue wherever required in that area will just fall there in one go. Nothing moves here. The print heads are fixed and the fabric moves over a conveyor belt, then goes to dryer and so on and so forth. Result, machine speeds. Single pass machines are becoming fast printers. Fabric speeds in these single pass machines could be 30 to 40 linear meters per minute, depend of course on the design, how much coverage that design has. Sublimation, which is the paper printing, can be done these days at 60 to 70 linear meters per minute, and people are hoping with little bit of more adjustment, higher speeds close to 100 linear meters per minute are technically possible on some single pass printers, inkjet printers. What does it mean? Now your speeds, if this happens, are close to rotary screen printing machines. So, investment may be higher, but you are going to be printing faster. So, economy can come in case you have larger orders. In contrast, of course, multipass machines where both the head and the fabrics are moving, achievable speeds are approximately a few linear meters per minute, all right. Therefore, it is slow, but for batch processes, piece good printing, t-shirt printing, That's the kind of speed is good enough. But for continuous printing of similar design, actually in a single pass machine, theoretically you can keep changing the design also with a program. That first few meters went to different design, the second few meters, 100 meters went for go for a different design. It's possible. Fabric doesn't have to stop, only design has to be changed. Expected quality in a multi-pass and a single pass. What do you think? Which is likely to give you a better quality? A single pass. In a multi-pass, different colors are going to be printed, different dots are going to be put at different times. If there is any change in position, any skewness, any vibration, any other thing, then it can fall somewhere else. In a single pass, everything is done in one go. So, there is no reason for us to doubt that the quality in a single pass is going to be better. The speed is faster, quality can be better. The new machines obviously are looking at better quality and also looking at more color gamut. And 8 color machines are also being used these days, which of course uses the original cyan, magenta, yellow, black, but light black, then red, green and orange are also been added. This gives more closer shades and design to the expected one. And why do people say that? Why all the 4s can't work? For example, in a monitor, only 4 and gives the standardization is much better. But here what you are expecting is that the dye molecule which is being chosen will exactly match the spectrum that is desired, which may not happen. You may try working very hard to create a molecule which will match that, but may be slightly off. Then you may have to compensate by another shade which can be mixed in the manner in which we are saying process colors, and you get a better shade, more close to the original picture. Therefore, people are now going to be using, have started using 8 colors also. Having talked about the machines, let us spend some time on inks and related problems, all right? Because inks are as complex formulation as well as the molecule itself design. So, the challenge that one has is what is the color gamut and how closely it can give you the right shade and design. You see something on the screen which you are liking, and then it has to be reproduced on a textile. Therefore, we just talked about before that you may like to use a correct dye, which obviously means the right molecule every time, and so you would get the right design. That is difficult, it is not so easy, and therefore, not many companies would like to make inks, fewer companies, because here you cannot afford to have variation in quality of the dye and the molecule itself. So, 4 color was good, but you may have to go for 6 and 8 as we talked about, that is one. But still, even in the 6 or 8 or 4, the molecule must be exact as best, every time the same. So, which 4 colors to be selected, then which class? Which class? Well, I am interested in reactive. So, molecule for reactive will be different. The acid, the disperse, all of them are different molecules, but we want the same color. It is not going to be easy. So, it is a big challenge, and that is the reason why from 4 color people have started looking at 6 and 8 colors to have a correct gamut, enlarged gamut. What about transfer printing? Well, something like that is done there as well. But the problem obviously is it only has dispersed dyes, because they are sublimable and they can be transferred onto polyester. And so, if you want to print silk, you want to print cotton, you want to print wool, nylon, no. So, it is going to be little more difficult. So, you may like to print by acids, reactives, and so on and so forth. And that is why another challenge that you have is different types of ink requiring different chemical compositions for fixation. The pre-treatment and the post-treatments may be different, and therefore, challenge of generating an ink is always there. That is why we said there are very limited number of ink manufacturers who would be making inks for inkjet printing. We just talked about why, because everything is complex about the molecule. We just said machine is complex, the print head is complex, yes, but the ink preparation is as much complex. We will just see in a few minutes. The standardization has to be done, that this particular thing will actually match the shade that is desirable, and every time the same result is to come. That is the standardization of the highest order, which in normal conventional printing people do have similar molecules, but they mix up to get the shades, they get chemicals which appear to be same, but they are not exactly same. But you, for a digital printing system, inkjet printing system, you cannot afford to have different types of molecules. Fastness properties, of course, are also required. So, you have a right kind of molecule, should have a right kind of fastness, light fastness, wash fastness, everything else. So, before we go a little further, why this whole thing is complex other than the chemistry of the molecule, the process dynamics itself. At a microsecond level, as the drop is forming and things are happening, this is the time when the drop formation takes place, and the ink stream as it is coming out happens in this small time scale. So, think of that, now you are really dynamic. On the other hand, at the millisecond stage, placement of dot, spreading, penetration takes place. So, you are having things very quickly being done, very fast. So, if there is a change in the initial time of drop formation, which is a microsecond range time, this is the one which will determine your size of the dot. So, some of the properties of the liquid, that is the ink, that is the fluid, have to be controlled, measured also, other than, as I said, the molecule. Therefore, the recipe may have other chemicals which may control viscosities and surface tensions and fluid flow. If that be so, one may have to measure Weber number, Reynolds number, which are obviously dependent on the viscosities, they are dependent on the velocities, they are dependent on densities and surface tensions. So, if somebody talks about various forces that are operational during the fluid flow, some of them are called inertial forces, which are related to this quantity, which is density, velocity and the diameter of the nozzle. Then there are other forces which are called the viscous forces. They are proportional to a dynamic viscosity, velocity and diameter. And surface tension forces, which are called sometimes the cohesive forces, are obviously proportional to the surface tension and the diameter. Now, when a drop is going to be ejected at high frequency, all small these things and small changes in these properties of the liquid, dimension of the nozzle and the velocity at which the drop is going to be ejected are going to be playing an important role, and so people have to worry about them. So, these terms are available in literature, which people obviously will be discussing. Those who make ink will be worried about these things, and so they must know. So, there is something called a dynamic viscosity, which is the resistance to shear when an external force is applied. The units are kilogram meter per second, meter per second, all right, or Pascal second. Then there is a related thing which is called the kinematic viscosity, which is the ratio of dynamic viscosity to the density of the fluid. The density term has come before also. So, it is the measure of the fluid resistance to shear under the weight of the gravity also, because if density is different, then the gravitational force also affects. Its unit is meter square per second. So, how this meter square per second comes is because of this. So, the kinematic viscosity is related to the density in this manner, and so the unit comes out a meter square per second. The Weber number is the dimensional quantity, dimensionless quantity. It characterizes the atomizing quality of the spray and the resulting droplet size. It is a ratio of the inertial forces and stabilizing cohesive forces. If the deforming forces increase due to higher speed or longer process lengths, the drops of the spray disperse more. So, whether you want dispersion or no, that is control. So, numerically or expression wise, this expression defines a Weber number, all right, which is dependent on density, which is dependent on the square of the velocity, which is dependent on the diameter, which is dependent on surface tension. So, if you really want consistent formulation, all these have to be controlled as well. Then there is Reynolds number, again a dimensionless quantity, ratio of inertial forces to viscous forces. If Reynolds number is small, viscous forces are dominant and the flow is lamellar. If Reynolds number is large, that means inertial forces dominate over viscous forces and flow is turbulent. Laminar forces generally would have Reynolds number in the range as this, less than that, and turbulent flow would generally be more than 10,000, right. The expression for the Reynolds number is like this, which uses kinematic viscosity. So, the drop formation, ejection is dependent on so many properties that we talked about. Let us see. The printing on a textile, for that matter, is possible if the ink is more likely to adhere to, let us say, different material in textile than to itself. So, cohesive forces within the thing should be in a way balanced to the adherence, which is the adhesive forces. The ink obviously must have a pigment or a dye, which is the right kind of a dye, and should be in a medium which controls its cohesive and adhesive properties. It would obviously have large number of components like solvents and binders. Binders obviously will be in a pigment ink. If you have a pigment ink, you have to have binder. Interesting. So, all of them will change the flow dynamics. Let us say drop formation. When a drop comes out of the nozzle, let us say, it takes up a shape like a, would like to take a spherical shape, which is because surface tensions that we have. But what happens is that before it is separated from the rest of the liquid, there is a trailing end. So, it is ejected. So, you have a trailing end which is like a tail, and then at some stage it will dissociate. Now, it is important how does it dissociate? What can happen if it does not dissociate correctly? So, individual ink drops are ejected from the nozzle by a pressure which is going to be imposed or impressed by the actuators. So, it will get pushed. As the drop exits the nozzle, a shape which is near spherical with a long thin trailing ligament. So, this is the trailing ligament and this is near spherical drop. How does it matter? The ligament subsequently breaks. Obviously, due to instability, something is being pulled out, something cannot go because the pressure is only that much. It sometimes breaks into fragments in many droplets. This portion can break into many droplets, which are called smaller droplets and satellite drops. Satellite. What happens? So, there is a print area on the textile, let us say, you have the design main drop, and you may find that there are some satellite drops also. They just also fall, they just broke because of the nature, the way you have it has to break sometimes. That is obviously not good for us. Satellite drops can create unwanted splash on the target substrate. Print quality obviously is going to be affected. Then what do we do? Can we control satellite drop formation? Yes, adding some viscosity builders. Remember, the ink has a low viscosity fluid, is a low viscosity fluid. We are not interested in high viscosity, obviously not like the way the print pastes are there, but increasing viscosity too much would mean more pressure has to be applied before a drop can come out. But a little bit of addition of a viscosity builder, which is obviously a polymer, to the ink can reduce the satellite drop formation, because the elastic stresses help the trailing ligament to be pulled into the main drop before the breakup from the nozzle occurs. So, because of the long chain, instead of becoming small droplets, it gets pulled into the main drop, and so you do not have satellite drop formation. So, that means you have to add something like this. So, the rheology again becomes important. So, you not only do the fluid dynamics and do the numbers, then you got to study the rheology also, control the rheology. Viscosity is low, stress should be low, actuators are very sensitive, may not be able to sustain high stress level. This has to be always remembered, but you still may have to modify the rheology. Then there is meniscus, which affects after the drop is formed. What happens to that? The shear rates which are low, the surface tension also will become an important part. Why? How much will be the fill up as the drop comes out? What is the cleaning of the nozzles if deposits are there around the nozzle versus it can just be cleaned? That will also be dependent on the surface tension things. Priming is where the head rests before starting the process. So, it gets cleaned. And how does it come in a ready to jet condition? All that is going to be related with rheologies. So, rheology modifiers therefore are there, as we said, for satellite formation or stoppage of satellite formation, you may have to change the rheology. So, you add some modifier which could be, say, viscosity of the ink, obviously we said is important. Sometimes molecular weights of the polyethylene glycol type of compounds with varying molecular weights may be added as viscosity modifiers. Although viscosity is very low, but rheology profile cannot be ignored. Jetting is breakup of the drop, which is again controlled by rheology. Small amounts of polymers demonstrate different breakup dynamics. In-flight fragmentation and detachment of nozzle. So, if we have some amount of polymers which modify the rheology, these two properties obviously are going to be affected. But if you have higher concentration, then it will adversely affect also. So, you can't just add the jetability is going to be adversely affected if the more polymer is there and viscosity is increased too much. Pressures also will be high, electronics may also not be able to sustain. The surface tension obviously allows drop formation, because higher is the surface tension, immediately spherical systems will win. But that also means that if the satellite drops are generated, they also like to go into spherical shapes, and so one will have to balance this. So, you want drop to get into a shape which is the spherical, but you still want satellite formation not to be there so much, and so surface tension cannot be too high as well. A lower surface tension will help interaction with the substrate also, so it can diffuse inside the substrate. And therefore, you may have surfactants also in the formulation, all right. So, surfactants are defined by their hydrophilic lyophilic balance values, which is the HLB, High HLB means more colloidal stability. A low HLB is for the low surface tension ink, can wet the nozzle, can maintain meniscus at the tip, can help in reliable jetting, and also can have interaction between ink and substrate. Dot and image quality can also be affected. Sometimes short chain ethylene glycol based non-ionic surfactants may be used. Ethylene glycol based non-ionic surfactant. Non-ionic means compatibility obviously is better. Ionic will obviously, based on which dye and we are using, can interact. Shear thinning is a property. When you apply shear, the viscosity goes down, which is basically a good idea. It is needed because you do not want to increase pressure. It is always better that when you apply shear, the drop, the fluid easily comes out of the nozzle and later on can have the same viscosity as required. So, shear thinning is that property which obviously would be needed. Startup, one would like the moment you push the button, the machine to start printing. It does not happen. There is something called latency. Latency is the number of firings needed to establish the first stable drop. So, if you have not used the machine, which people should not do it, but if you do not have work, then you may have to stop the machine. You will probably have to clean things, make sure that no deposits are there, but still it will take some time. That is called the latency. Reliability, of course, startup, if there is an issue, sometimes water based inks. Near nozzle evaporation means there is a deposit of solid, which will cause obstruction to the flow and change the drop volume and drop size. Poor image quality can result. Self cleaning, but very important thing, that is there should be have some solvents in the ink that if anything gets deposited around the nozzle diameter, then it gets redissolved from the nozzle surface and becomes part. So, there are no solids, it gets dissolved. So, the startup could be easy. So, less volatile organic solvents can help this. Some of the examples are ethylene glycol, diethylene glycol, butanol, some urea, etc. So, this section we just talked about the dynamics of ink flow, rheology and its role. Viscosity of the ink is low, but because system operates at very high frequency, a small change has a significant effect. Viscosity control is important, surface tension control also is important. We discuss little bit now before we close this session, what type of inks are available in the market and what can they do. So, one of the most important ink that is available is pigment ink. So, the color is pigment, it is not a dye. I am sure you understand the difference between a pigment and a dye, all right. So, we are talking about pigment inks. What are the advantages of pigment inks? The most important advantage is it can print all substrates. It can print blends. So, becomes important. Process simple, print, dry, bake, you are done. But just to give a glimpse of what a typical pigment ink formulation may have. Of course, it has a pigment dispersion which is required. There may be a binder. Pigments do not have affinity for substrate, so there is a binder. I mean, one would have loved to have a binder outside this ink, but which is not technically a very good idea, and therefore the good type of binders are being used in the ink itself. So, most water based inks are there, aqueous, a co-solvent may be there for wetting and adhesion to improve jetting properties. Co-solvent is the one which can dissolve, the dye or systems little better. Surfactants to control surface tension, humectants to make sure there is water always remains at some portion or the other. Anti-foaming agents, because the frequency is high, it should not foam. Viscosity modifier or a controlling agent, and of course a biocide, because you expect these inks to be stable for a long period and don't want any fungus etc. to develop. Long period means years. What is the expectation? One of the expectation is shelf life. People may say, well, up to 2 years we like to have a shelf life, pretty high. Low viscosity, reliable jetting, good washing and rubbing fastness, of course. So, the wash fastness and rubbing fastness depend on how the binder, for example, finally makes a film and the pigment is embedded inside. Obviously, binder is there, so we expect no clogging in the presence of binder. So, binder has to be a different kind of binder. The particle size of the pigment has to be controlled. Generally, it is in the range of 0.05 to 0.15 micron. Distribution should be as sharp as possible and not broad. If there is a broad, that means there are particles which are very large size which will clog at some stage or the other. So, big particles will do settling, clogging and cause problems in startup and jetting. Below 0.05 microns also is not a very good idea, because the overall surface area becomes very high, surface energy becomes very high, and so these particles will always have a tendency to agglomerate and then cause problem in a different ways. Keeping very small particles in a dispersed phase becomes more and more difficult when the particle size becomes smaller and smaller, because surface area becomes so high that the particles have a tendency to come together. The binder, as we say, required, because they are the film forming substances and they are going to be part of the ink, as we said, should have a low Tg, so that after the binding has been done, the fabric in the design area is also as flexible, because we do not want to change the flexibility. Storage stability, coagulation and phase separation can occur because of these binders, and which is not a good idea, and therefore one would like to have materials which would not phase separate or coagulate easily. Otherwise, reliable jetting will be affected. Clogging will happen. Now, the last question that we may like to answer as far as the pigment inks are concerned: can we not use the binder in the pigment inks? So, what do? We need to somehow fix the pigment particle, which is by film formation. So, how do you do that? Okay, we can apply the whole binder to the fabric in a pre-treatment and then print and later on do something. Even if you are able to do it, that would mean that portions of the fabric which do not have a design also have a binder, right. Let us say only 25% has been printed, which would mean 75% which is not printed also has a binder. I mean, that is something people do not like. Then we have special inks like reactive inks, which is only for the textile. And which kind of textile? cotton, viscose, silk, all of them can be printed by using reactive. The ink chemistry, basically, as far as the dye is concerned, the dye is a dye, but the reactive group could be this, which is called the monochlorotriazine group, or vinyl sulfone group, which is something like that. So, generally this is the kind of chemistry that you may be having for the reactive groups, but they can be applied to viscose, cotton, yeah, why not, nylon also, and silk. Wool can be also used, but printing of wool normally is not very popular. Then acid inks, which are acid dyes, can go and print, let us say, you can use them to print silk, wool, nylon, leather, sure, but they make ionic bonds, they do not make covalent bonds like reactive dyes. So, ionic bonds. Fastness obviously will depend, because ions can dissociate during washing and can come out. Affinity obviously of these dyes should be high for the substrate, as high, and one would prefer dyes with lower solubility in water, acid dyes with lower solubility in water, because then wash fastness will be obviously higher. Disperse inks are also available. They could be using dispersed dye for transfer printing, which are sublimable. They can be printed on paper, and once you put on the paper, then they can be transferred to a textile substrate, which is polyester normally. So, which would not require any post treatment, because just the washing etc. may not be required, because the transfer takes place during the transfer process. All right. The direct printing onto textiles can also be done by dispersed dyes, but they will require pre and post treatment, and dispersion process of course will be same. One of the dye is sublimable, the other dye would have higher sublimation fastness. Generally aqueous dispersions like pigments, wetting of the dye particle is facilitated. You have surface active agents or dispersing agents. Dispersions are similar to pigments. Generally you may have a solid contents of 20%, solid content of 20%, rest may be solvents or water. Again, particle size is again controllable like a pigment, because they are not water soluble, therefore they are particles, but they are dyes, remember, dispersed are dyes. In a nutshell, if you look at that, so you can have acid inks which can dye silk, wool, nylon. A pre-treatment would be required so that you have an acid donor, because they require acid medium. Post treatment, steam or wash. Reactive obviously make covalent bonds. Cotton, wool, silk, rayon, they will require, for cotton and rayon you may require alkaline medium, for wool and silk you may require neutral medium. You have to do steam and wash. Disperse obviously for polyester generally, but theoretically you can also have they can be used for nylon or acrylics, but normally not used. Pre-treatment may be just a thickener to make sure there is a uniform surface, and high temperature steam and wash, or you can have thermosoling also and wash. Pigment can be for all fibers. Actually you do not require any pre-treatment unless the surface is rough. So, you give some pre-treatment to make sure surface is all right. For post-treatment you only have dry heat, and that is it. You would be having a good design. So, that is in a nutshell. So, we did talk about types of inks, what type of substrates can be printed, if they require any pre and post treatment based on the type of ink. Final word people obviously will take about cost of printing. Why digital printing or inkjet printing is not so popular as, let us say, rotary screen printing? Simply because of the cost. The costs are coming down. If the cost becomes equal to approximately the rotary screen printing, this will become a useful technology. The speeds are increasing, as we said, based on single pass machines, and so we hope in near future we will be able to get cost comparable to the conventional printing costs. So, printing cost, if one looks at the screen printing cost, if you have very short runs, is higher than digital or inkjet printing. It becomes lower when the runs are higher. So, if you have to make 5 meters, 10 meters print, then inkjet will be cheaper. But on a long run, print run, 1000 meters, 500 meters, 10,000 meters, obviously at the moment this is there. The cost of digital printing more or less remains same, because ink consumption will remain same, design making is, the machine cost remains more or less same, just a little bit extra cost could be if the runs are shorter, because continuous production may get affected. So, cost depends on what? Print area, so more print area, more ink cost, machine cost, but which is constant, no problem on that. The main thing is print head replacement, because if print head gets choked, it has to be replaced. That is a big cost. The print head cost therefore determines the cost of the machine, the operating frequency, if it is high or low, the cost per nozzle, how much is there, which has to be calculated, the sturdiness of the print head, how will it fail, how much will it fail, what is the failure rate, all that will add to the recurring cost of a print head replacement. So, strategies. People are now having strategies. You may not be advised that you use any ink that you want to use. The machinery manufacturers, the print head manufacturers are different people. Ink manufacturers are different people. Together they shake hand, they collaborate, and they say this type of print head which uses this type of an actuator can use this type of an ink, and we warranty that will last for so many, let us say, so much time of printing, so much area of printing. If you use some other ink not suggested by the print head manufacturer, then you may get a different performance, you will be responsible for that. So, strategy is machinery manufacturer and the print head manufacturers, ink manufacturers are collaborating together to say, well, these kind of heads will be good for these type of inks, and so use this. The machinery manufacturer also will use the same head, similar type, and also suggest similar type of inks to be used. That appears to be a good strategy at the moment. So, this brings us to the end of the inkjet printing module. Hope you enjoyed these. Well, the technology is large, knowledge is even wider. This small little interaction that we have had through this lecture discussion may not be enough. In case you want to learn a little more, well, you can look at one of the books, which is an interesting book, very nice book on digital printing of textiles. and I'll also later on refer some publications which you may also read and get a little more insight on the topic of inkjet printing. See you sometime soon. Have fun. All the best. Thank you.